Yes, guys, good afternoon. Today, let's start the topic half-range Fourier expansion. In previous topic, we have discussed Fourier expansion of a function over the interval minus L, L. Now, suppose if we wish to expand f of x over the half interval 0, L in a Fourier series that contains only cosine terms or only sine terms, then let's define a new function. Irrespective of odd function or even function, you will expand the given function completely in cosine term or completely in sine term. Okay, fine. For this purpose, let's define a new function phi of x, which is equal to a split function f of x for 0, L and f of minus x for the interval minus L, 0. And here, this is for the interval minus L, L. And you can just see that phi of x is an even function. See here, if you want to check how this phi of x is an even function, just replace this f of x by any function. For example, take f of x is equal to x. If you take this f of x is equal to x, then f of minus x will be minus x. And I have given you how to decide the even nature and odd nature of a split function. By that way, you can decide that the given split function is an even function. And this is for the interval minus L, L. And hence, the Fourier series expansion of phi of x over the interval minus L, L is, you know, what is the Fourier expansion for a function over the interval minus L, L. That I have written it here. Okay, let me zoom it. Phi of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by L x, because bn is equal to 0 for phi of x is an even function. Okay, where a naught is equal to 2 by L integral 0 to L phi of x dx, an is equal to 2 by L integral 0 to L phi of x cos n pi x by L dx. Okay, see here, phi of x is an even function. Here, phi of x is an even function. We are not talking about f of x or f of minus x. Okay, here phi of x is an even function. I have took the example x. Okay, but x need not be an even function. X is actually an odd function. Name these equations as 1, 2, and 3. Okay, and since 1 is valid for all x in minus L to L, it is valid for the overall interval minus L to L, then it is valid for all x in 0, L also. Okay, half of that interval. But in 0, L, this phi of x is equal to f of x. See here, in this particular interval, phi of x is equal to f of x. So in place of phi of x, I am writing f of x. So this 1 becomes f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by L. And similarly, a naught and an. See here, 2 by L integral 0 to L f of x. Similarly, an, 2 by L integral 0 to L f of x cos n pi x by L dx. See here, in place of f of x, in place of phi of x, I have written f of x, because in this interval 0 to L, phi of x is equal to f of x. And RHS of 4, this one, right hand side of 4, equation 4, represents the Fourier series for f of x over the half interval 0, L. And this contains only cosine terms and is called as half-range Fourier cosine series for f of x over the interval 0, L. Okay, if you want to write what is the Fourier's cosine series for the interval 0, pi, you need to just replace L by pi. For L equal to pi, you have f of x is equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx, because n pi x by pi will be just cos nx, and where a naught and n, here also you should do the changes accordingly. You should replace L by pi. Okay, fine. Similarly, if you define for psi of x as an odd function, how to write an odd function? In split form, f of x for 0 comma L minus f of minus x for minus L comma 0. See, you take any function. Okay, if you take f of x equal to x or x square, you just substitute here. This becomes an odd function. Okay, which is an odd function over minus L comma L. Here also you will continue the same as we did in the previous one, that is for even function. In this case, a naught and a n 0, b n not is 0. Okay, so f of x is equal to summation n equal to 1 to infinity b n sine n pi x by L, where bn is equal to 2 by L 0 to L f of x sine n pi x by L dx. And here RHS of this 7 represents Fourier series for f of x over the half interval 0 comma L and contains only sine terms, and therefore it is called as half range Fourier sine series for f of x. Okay, and that is for the interval 0 comma L. And for L equal to pi, you should just replace L by pi. There you'll get the half range Fourier sine series for f of x over the interval 0 comma pi. Okay, change accordingly. Okay, fine. And let me make a note of all these formulas quickly. See here, for the interval 0 comma L, what is the cosine series? And what about a naught and a n? What is sine series? F of x is equal to so much, where bn is so much. And similarly, for the interval 0 comma pi, I have just written those formulas in this note. Till now, what I have told you, I have written those formulas here. That's it. Okay, make a note of this. For the interval 0 comma pi, what is cosine series? What is sine series? Okay, you can just go through these formulas, and before you start working out the problems based on half range Fourier sine series or cosine series. Okay, let's start up with the problems, guys. Obtain the half range sine Fourier series of f of x is equal to x square in 0 less than x less than pi. See, here also you will use the, see, if they ask you to obtain the half range sine series, you should use that particular formula, half range sine series. If they ask you to obtain the half range cosine series, then you need to use that particular formula. And here the given function is x square. Accordingly, I will use those formulas. See, half range Fourier sine series is given by f of x is equal to summation n equal to 1 to infinity bn sine nx for the interval 0 comma pi. Okay, so where bn is equal to so much, and this you will be integrating using Bernoulli's rule of integration by parts. Okay, and here this vanishes both for upper limit as well as lower limit. Only the first and third term exist, and I have written that here both for upper limit as well as lower limit. Okay, and after simplifying you'll get like this, and at last you will need to substitute the value of bn here in this expansion. Okay, this is all about half range series. Okay, let's do another problems. Okay, second one. Yeah, second one, expand the function f of x is equal to x for 0 comma pi by 2, pi minus x for pi by 2 comma pi in half range cosine series in 0 comma pi. So here the interval is 0 comma pi, but you need to use half range cosine series. Okay, and the formula for half range cosine series in the interval 0 comma pi is f of x is equal to a naught by 2 plus summation 1 to infinity a n cos nx, where a naught is equal to 2 pi pi integral 0 to pi f of x dx, And 0 to pi by 2, you have f of x as x. And for pi by 2 to pi, you have f of x as pi minus x. Okay. So accordingly, you need to split the integral. Okay. And then you need to integrate. X is x squared by 2 and pi minus x is pi x minus x squared by 2. After applying the upper limit and lower limit and after simplifying it, you will get pi by 2 finally. Formula for an is equal to 2 pi integral 0 to pi f of x cos nx dx. And what is f of x? You have two intervals. For 0 to pi by 2 it is x, and for pi by 2 to pi it is pi minus x. And here also you should use Bernoulli's rule of integration by parts. Okay, and after applying the upper limit and lower limit, you have this. Okay, and you should use this in and a naught. Okay, here in the expansion of half range cosine series, then you'll get the final answer. Okay, see, this is all about the second problem. Let's move on to the next problem. Obtain the half range Fourier sine series of f of x is equal to x minus 1 whole square in the interval 0, 1. See here, the interval is 0, 1. You need to replace that L by 1 here, not pi. Here the interval is 0, 1. Therefore, the half range sine series for the given function f of x over 0, 1 is f of x. See, first I have written for 0, L. Then I have written with L equal to 1. That is the Fourier range sine, Fourier's half range sine series for the interval 0, 1. Okay. Later I have substituted the value for L equal to 1. So your half range sine series looks like this. Okay, where Bn is equal to so much, and here also you need to substitute for L as 1. And for this, again, you need to use the Bernoulli's rule of integration by parts. So this is how it looks like. Similarly, this one you should take for differentiation and this one for integration. Okay, then you should go on integrating using Bernoulli's rule of integration by parts. Okay, then after using upper limit and lower limit, you will get like this. And this is how you need to simplify. And after getting the value of Bn, finally you need to substitute it in the half range sine series. Okay, so this is all about today's class, guys.